All right, you need to have out worksheet 11, which says getting ready for the quiz on 9 to 10-2. Okay, there are several questions on the quiz that it would be beneficial to solve graphically. This first one says, which appears to form an identity. So we're going to need to type this into our calculator and see which one of these match it. Now, if it happens to be sine or cosine, we'll recognize it right away. Otherwise, we might have to type these in y2 and see if they happen to match this guy. But let's type this first one in very, very carefully. We're going to need parentheses around the top. And we're going to need extra parentheses around this whole thing with a squared and around this 2x. And then in the denominator, this is going to have to be a 1 over sine. All right, so let me pull up my calculator here. And I'm going to be in radians. And I'm going to start with a parenthesis. 2 times parenthesis sine x close close squared plus 2, nope, back up, plus cosine 2x close, and then close the whole top of the fraction, divided by, and I'm going to put a parenthesis even though I don't need it, but cosecant is 1 divided by sine x, close, close, to close off that whole denominator. And then I'm going to do a zoom trig. And I think I recognize that. Okay, that looks like a sine graph to me. So I'm going to choose that choice, but to double check, I could go in and type sine of x in my y sub 2, and if I wanted to be really fancy, I could back up over to the left and make it bolder, so it should graph the first one and then go over it with the sine graph, and it is going over exactly the same place. Okay, so the right answer was choice B. I'm going to rewrite one more time what I typed just to clarify that. It was parenthesis 2 sine of x all squared plus cosine of 2x, and then close all the top, divided by 1 divided by the sine of x. Okay, if I had to type in choice A to test it, it would have been 1 minus sine x divided by cosine x, and graph that in y2 and see if that happened to match, which we know it didn't, but I just want to make sure you know how to type these. And C, if you'd been typing that one in, would have been 1 plus 1 divided by cosine, sorry, not sine, all divided by 1 over cosine. And you could have put an extra parentheses in here around the 1 over cosine, but it wouldn't matter because it always does division before addition anyway. All right, so practice in typing those in to see just graphically which one matches. That's all you were trying to figure out. It's a multiple choice question. All right, problem number 2. It says test to determine whether it might be an identity. Again, we're just going to graph in y. Sorry, in y sub 1 we're going to graph the tangent of x plus 1 divided by the tangent of x, which is the cotangent. And then in y sub 2, we're going to graph 1 divided by, and just to make it clear, I'll put it in parentheses, but sine of x times cosine of x. And see if it's an identity, yes or no. Sorry. So I have tan x plus 1 divided by tan x and then I have 1 divided by the quantity sine x times cosine x. And I'm in radians, and I'm just going to do a zoom trig. Okay, I'm not seeing anything new come in, so it seems like they might be the same. So I could go down to this one, back over to the left, and make it go over that one again with a darker one to see if they are exactly the same. I could also think about doing a proof of this, though it did say determine graphically. There it goes right over the top, so they are equivalent. Okay, so that one is an identity. Problem number 3. Says prove that this is true. Well, cosecant is 1 over sine. Cotangent is cosine over sine. And those are all 2x. If I combine those, I get 1 plus the cosine of 2x all over the sine of 2x. And on my identities sheet, I don't have anything on my identities sheet that looks exactly like this. So let's keep going by trading out some sines and cosines here. For this, we have several choices of what to trade it for. Since there's a plus 1 up here, I think I'm going to trade this for a 2 cosine squared minus 1, because that will get rid of this 1 out here. The denominator I only have 1 trade for. That trades for a 2 sine of x cosine of x. So this will become 1 plus 2 cosine squared minus 1 all over 2 sine of x cosine of x. Now, some things are going to cancel, but we need to be really careful that we don't cancel anything until the addition and subtraction are taken care of. So I'm going to rewrite that step. then I can cancel one of the cosines and the 2, and I'm left with cosine of x over sine of x, which is the cotangent of x, which is what the right-hand side said. Okay, make very clear steps when you're doing these. All right, hopefully that's enough time for you to write it down, otherwise your sub can pause if you need more time. I'm going to move on to the next one. Number 4 says, prove this identity. What I am going to use is the sum formula for sine. The sum formula on our sheet says sine A plus B equals sine A cosine B plus cosine A sine B. So you need to expand this left-hand side using that idea. It will be sine of x times the cosine of b, which is 2 pi, plus the cosine of a, which is x, times the sine of 2 pi. Then we're going to go to our unit circle. And over here at 2 pi, it says 1, 0. So the cosine at 2 pi gets traded out for the value of 1. And at 2 pi, the sine is 0. So all we're left is the sine of x. Because 1 times sine is sine and 0 times cosine is 0. Okay? So as long as you showed all those steps or crossed this out even and wrote 1 and 0, I would be able to follow it and you should be good. Just make sure I can see that you've written out the sum and substituted in the values and shown that it simplifies down to whatever it says here. Right. Question number 5 is a sum and difference question again. It's the cosine of a plus b. So copying that right off the sheet, it will be cosine of a, cosine of b, minus sine of a, sine of b. All right, our a is pi over 4, and our b is x. Now, pi over 4 values we're going to get off the unit circle, but we have to use this information for the other half of the story, for this cosine of x and sine of x. It says right here the cosine is negative 2/5, but to find the sine we have to draw the picture, pi over 2 and pi, all right, 90 and 180, so we are in quadrant 2. Cosine is adjacent over hypotenuse. The x would be negative and the y would be positive. If I'm finding that value and I do Pythagorean theorem, I get 25 minus 4 is 21. So this side is the square root of 21. And it's positive. In this quadrant, the y is going up. So for this picture, the sine of x is going to be opposite over hypotenuse, or square root of 21 over 5. So using my unit circle, the cosine at pi over 4 is square root of 2 over 2. The cosine of x, from right up here, is negative 2/5, minus the sine at pi over 4, which is square root of 2 over 2. and the sign at x, which we just evaluated to be square root of 21 over 5. So when I multiply these together, I get negative 2 square root of 2 over 10 minus square root of 2 times square root of 21 is square root of 42 over 10. 42 doesn't have any perfect squares in it. So this is a lovely answer of negative 2 square roots of 2 minus the square root of 42 all over 10. And actually, because this doesn't simplify, that doesn't reduce at all, and I'm checking my answer because that's just nasty. Yep, that's what I have on my answer key. Otherwise, you could have left it like this and reduced just this one. Would have been negative square root of 2 over 5 minus the square root of 42 over 10. So that answer would have been okay, or this answer. I don't know that it's quite that ugly on the quiz tomorrow, but you do have to expand one of these out and substitute values in where some of the values come from the unit circle and some come from the information given. Okay? And it's probably honestly better to leave it and say, and let me take off half point that you didn't simplify it far enough than to try to cancel out a bunch of stuff and get it wrong because you did that. All right, so make sure you have that copied down, and then we're going to go on to the next one. All right, I paused that for a second, so I hope it's recording again, and I'm going to move on to number 6. It says find all solutions, and this is really nasty. Tangent squared equals negative square root of 2 over 2 secant of x. We could probably do some trading and maybe move some things over and factor and all this stuff, but there's a couple of these on the quiz tomorrow where your best bet when it's multiple choice is to graph. If we graphed in y1, tangent squared, so in y1 I'm going to type tangent of x squared, and in y sub 2 I'm going to type negative square root of 2 divided by 2 times 1 over cosine of x. And if I did them in y1 and y2, then I'm looking for the intersection points. So then I'm going to type in, I'm going to put in my choices here and see if they land at the intersection points. All right, so I'm going to go to my calculator. And in y sub 1, I'm just going to put parenthesis tan x close squared. And in y sub 2, maybe I'll put parenthesis around that just so we're clear on what that is. Negative square root of 2. And I want to get out of the square root, or just close the parenthesis if you were using an older calculator. Divided by 2. And close that parenthesis. So I have negative square root of 2 over 2, and then times 1 divided by the cosine of x. Right? I think a zoom trig is a fine window, so I'm just going to do a zoom trig again. We'll see if it's not good. We'll figure it out. All right, so tangent was squared, so it came out with only positive answers. And then we had a funny stretched secant graph. All right, so it wants the answers between 0 and 2 pi. So I guess I could change my window to just be 0 to 2 pi. You wouldn't have to, but that will help us see them clearly. So I made my x window 0 to 2 pi. I'm going to let it regraph real fast. And I'm looking for the intersection points. It does clearly show that there are only 2 intersection points between 0 and 2 pi. So I'm gonna go trace, and I'm gonna try 3 pi over 4, which is from choice A. And what do you know, it jumped right to one of those intersection points, so let's try 5 pi over 4. And it jumped to the other intersection point, so I think we're okay to pick choice A. If we had tried the pi over 3, okay, it was not an intersection point. And, you know, it is possible that one of the answers on the quiz is none of these. If you've carefully graphed it and the choices don't jump to the intersection point, then you'd have to pick none of these, okay? So we were able to be successful with choice A. And I did put this in a parenthesis just when I typed it in, just to make it nice. And I did set my window to 0 to 2 pi. All right. And I believe even on the quiz it says hint graph if that's what my suggestion was. All right, I am gonna shut this calculator off the screen here and move on to the next one. We could do this the same, I think, just to be different and talk about another, you could graph this for sure and type in your choices. But I think secant squared is a trade that we could do here. A secant squared is a 1 plus a tangent squared. And then it says plus a tangent of x, whoops, equals 1. If I subtract 1 from each side, I'll have the tangent squared of x plus the tangent of x equals 0. If I factor out a tangent of x, since they're multiplying to make 0, I have where is the tangent equal to 0? Or where is the tangent equal to -1? Tangent is -1 in this quadrant and this quadrant at some pi over 4s. So I'm thinking this is 3 pi over 4 and 7 pi over 4. And the tangent is 0 on our unit circle when y is 0. So out here at 1, 0, y over x would be 0, or over here at -1, 0. The tangent would be 0. So I'm thinking it's 0, pi, 3 pi over 4, and 7 pi over 4, which looks to me like choice B. Okay, if you had chosen to graph that into y1, you could have typed parenthesis 1 divided by cosine of x, and then you could just square the whole thing, because 1 over cosine quantity squared would be secant squared, and then say plus tangent of x. And then in y2, you could have just put 1 and found the intersection points and tested all your choices. As long as it's multiple choice, you can just test the choices. Okay, I'm not going to bother to show that one by graphing. All right, number 8. This one says find exact solutions, and it isn't multiple choice, so we need to find another way to solve it. This is one I feel like we've done 100 times. We're just going to take out the sine of x. That will leave 2 cosine of x minus 1 equals 0. If we set each part equal to 0, the sine of x is 0, or 2 cosine of x minus 1 equals 0. So we're looking on our unit circle from where the sine of x is 0, or the cosine of x is 1/2. And I could even pull in a unit circle here. All right, and I I needed to know where, I lost it. The sine is 0, right? The sine is the y value, so that's at 0 and pi. And the other one was where the cosine is 1/2, and that is at pi over 3 and 5 pi over 3. Now, it says all exact solutions. So you could list all 4 of those. And I just went brain dead. We had pi over 3 and 5 pi over 3, right? And then put a plus or minus 2 pi n on the back of each. Those of you who are good with the shortcut answers, since 0 and pi are straight across from each other, you just could have said 0 plus or minus pi n. And because pi over 3 and 5 pi over 3 are exactly pi over 3 or 60 on either side of the origin, you could have said plus or minus pi over 3, plus or minus 2 pi n. So that's the shortest way to write all solutions, but I would have taken these 4 over here, as long as they all had a plus or minus 2 pi n on the back, or any combination thereof that makes sense, okay? Then we get to number 9, and we're just looking at law of sines and cosine stuff again. It says we have some triangle ABC. Side A across from angle A is 15, side B is 11, and that's across from angle B, and side C is 21, across from angle C. It says find angle A specifically, so that's the one you need to find, okay? Be careful you're finding the right one. It is across from the side of 15, so we're going to use law of cosines, which should be on the new unit circle you've gotten. And I don't know if it's the right form or not, but we're going to do 15 squared equals, and the 2 adjacent sides are 21 and 11. And then it's minus 2 times 21 times 11 times the cosine of angle A. Remember, all of this is multiplied together. You can't simplify that over there. So we're going to subtract a 21 squared and an 11 squared over to this side. So if I type 15 squared minus 21 squared minus 11 squared, we get negative 337. And over here, I got rid of those already. So I have left a negative 2 times a 21 and an 11. All right, then I need to divide. I'm going to end up with 337 over 462, and that's the cosine of some angle. So I'm going to type second cosine of, and you can have a decimal or the fraction, doesn't matter. I just got rid of the negatives because a negative divided by negative is positive. Okay, I should be in degrees for this question now because it wants the angle in degrees. You're going to have to be careful on switching back and forth. You need to be in radians if the question is dealing with radians, okay? If there's some pi over 4 answers or you're graphing. But if you're solving for an angle, I don't think it wants radians. We're going to go second cosine 337 divided by 462. And I got 43.2 roughly degrees for the measure of angle A. All right. So there will be a problem tomorrow where you have to work law of cosines backwards, and you need to know how to do that. Right, number 10 says we're given a triangle. Side A is 2, angle A is 39, B is 32 degrees, and what is the length of side C? All right, I need to find the missing angle. So 180 minus 32 and 39 is 109 degrees over here at angle C. My picture isn't even close to accurate. But then I can just set up the law of sines to find side C. So the sine of 109 is across from angle C in the same way that the sine of 39 degrees is across from 2. If I cross multiply and divide, so I type 2 times the sine of 109, close my parentheses, divided by the sine of 39, and I got C equals 3 units, whatever that is. It's the length of side C. All right, so make sure you can find missing sides and angles by law of sines and law of cosines. Number 11 says solve the whole triangle. There is one of these on there. Yuck, yuck, yuck. We have to find all the missing pieces. So we have a 45-degree angle, a 52-degree angle, and the easiest thing in the world to find is angle C then. If I do 90 minus 45 and 52, I'm sorry, 180 minus, yep. Must be late. So I'm brain dead. Okay, we get angle C is 83 degrees. So we found one thing. Now it said side B is the only side given is 68 units long. So we can set up to find side C and side A. And we need to be in degrees because these angles are in degrees. And then we're just going to cross multiply and divide to 68 times the sine of 83 divided by the sine of 52. And for C, I got 85.7 units roughly. And then 68 times the sine of 45 divided by the sine of 52. I got 61 units roughly for side A. It may specify tomorrow what to round to. If it doesn't, just round to the nearest tenth is fine. Okay, and I think on a question like that where it said solve, I made blanks for everything so that you wouldn't forget to solve for all three things. All right, I'm going to go on to number 12. Be very careful. It says find the area. This is an area of a triangle given the sides, all three sides, so I'm going to use Heron's formula anyway. You could do law of cosines backwards and find one of the missing angles and then use your 1/2 AB sine of C. But Heron's formula says I want the semi-perimeter, which is add them all up and divide by 2. 28 plus 24 plus 20 is 72. Divided by 2 is 36. And then it says the area is equal to S times S minus A times S minus B times S minus C. If you want to store 36 on your calculator as X, you would type 36 and then that STO with the triangle and then into X, and then all these S's would become X's. I'm just gonna write it out. It's gonna be 36 times 36 minus 20 times 36 minus 24 times 36 minus 28. And then I'm going to square root when I'm all done with that. All right, I double checked and did it twice. I got 55296. So if I square root that, and some of you probably put the square root in right away, it doesn't matter. I have 235.2, and again, there was no units, but it would be square units because it's area. There may be units on the quiz tomorrow, I'm not sure. All right, sorry, there I paused that again, so I have no idea if I've waited long enough for you to finish this question or not, but I'm gonna go ahead and move. If there's another question, I don't even know if there is. There is not. Okay. Well, I am going to take 1 second here to pull out my answer key for tomorrow's quiz and see if there's anything else that I want to review with you. Real quick, there are a couple easy trade questions where, you know, maybe it says something crazy like the square root of 1 minus the cosine of 64 degrees all over 2 equal, and you're supposed to simplify. So if you looked at your sheet, you would say, well, that's sine of something over 2. Is this 1 minus business under a radical? So then if you put this in here, you'd get the sine of 64 over 2, or 32 degrees. So there's some of that, like we had on the last quiz. There are a couple trade, you know, prove the identity questions where you have to actually do the proof, and then there's a couple graphic ones. There's a couple where you have to factor and find all exact solutions, or solution 0 to 2 pi, and some of those it's okay to go ahead and graph, doesn't matter. If it's a multiple choice one, you can graph anyway. And then there's this law of sines and cosine stuff. There are 2 application problems. One is a parallelogram. So you have to find one of the diagonals, okay? So what you need to remember is, I'm just going to make something up here. If this is 30 degrees, then this is 150 because those are consecutive interior angles. If it said this was 10 and this was 18, and it wanted the longer diagonal, you'd do law of cosines going this way using the 150. If it wanted the shorter diagonal, you'd go this way and use these 3 numbers to find law of cosines here, okay? But that's pretty much it. And then there's one, we did about 6 of these, I think, on the law of sines and cosines packets and stuff, but if we have 2 people 1,000 feet apart, and one has to look up 40 degrees to the top of the tree, and one has to look up 50 degrees to the top of the tree, we need to find the height of the tree here. So we're going to treat it as one giant triangle first. You know what? I'm going to make this 30 over here. So we have a 30 and a 50. That leaves a 100-degree angle up here. So if we did the sine of 100 is across from 1,000, in the same way the sine of, I'm going to call that guy x. Sine of 50 is across from x. Once we've found x, which I'll go ahead and do just so you have a concrete example here. 1,000 times the sine of 50 divided by the sine of 100. This would be 777.9. Then to find the height, you're just using this little triangle right here. So you could do law of sines again, you could do sine equals opposite over hypotenuse. In my silly example, you could even do a 30, 60, 90, because I used 30 degrees, but all right, that's how you'd find the height. All right. I think that covers everything that's going to be on the quiz. Hopefully this has not gone too long.